Hi everyone. Recently I uploaded a short video on mathematics for machine learning where I got a comment saying they want a detailed video on mathematics for machine learning. So here I am with the video. So let us get started. So here I will be talking about the mathematics or the basic essential requirements that one should fulfill before beginning with machine learning. Before we are discussing different machine learning algorithms, but if a person don't know basics of machine learning, then they will not be able to understand this algorithms very clearly. So I thought of making this videos. We will be continuing with our algorithms part. So let us get started with this video. So, firstly, the very basic thing. This is actually not in the list, but these are something that we must know. So, I will say that we should prefer the NCRTs or any 11th class book where they talk about. We should all obviously know this. This is, I mean, bare minimum that functions is something that one must know before starting with machine learning. So this domain and range, a very basic topic in machine learning, or even in so even 11th class students know about this. Then we have linear functions, quadratic, different type of functions. So these are something, so graphs of functions, logarithmic functions, then sigmoid functions. So there are multiple type of functions that you need to focus on and study about them before starting. If you don't know, if you know, it's a very good thing that you know it from before, but if you don't know, I would say that it is good to know things. Then we have linear algebra. This is very important, I would say, for machine learning. So in linear algebra also, so basically vectors are something that you can't ignore. Then matrices vectors, they are like, if one comes, it is like buy one and get one free. When we talk about vectors, uh, so matrices will automatically come with them. So basically, how are vectors represented, their additions, their scalar multiplications, then we have dot product, norm, magnitude, and then so this continues. So distance between vectors. So these are some of the topics in vectors that you should know before starting machine learning. Eigenvalues, eigenvectors, these are also good to know topics when it comes to vectors. Then next we have matrices. So basically, as I said, whenever we talk about vectors, automatically matrices come with it. So basically, there is something in machine learning that we call it as confusion matrix. Very soon I'm going to make a detailed video on confusion matrices. Matrix, basically, when we are going to talk about some performance measures like accuracy, recall, precision, F1 score. So there are multiple such uh, accuracy, and there are a lot of performance measures that we are going to study very soon. And all of this, so there comes the matrices. So basically we have a concept of confusion matrix where we have values like false positive, true positive. So and then we are going to define how exactly different performance measures are and how do they work. So they also have some kind of formulas. So we are soon, very soon, we are going to make a detailed video on it. So matrices are something that we should know, like not very detailed concepts, but very small things like what are basically what is the condition when it comes to matrix addition, matrix subtraction, and very important is matrix multiplication. So what are the conditions that one should satisfy before thinking of the matrices addition, subtraction, and what is exactly the transpose, inverse. We need not to go in very detailed. So these are like diagonal, what is identity matrix. So these are very basic things that we should know. And what is a symmetric matrix, diagonal, anti-diagonal. So this small terms that are there, so it is always good to know all of them. And matrices is a are like very vast. It is a very vast topic. Whenever you get into it, so you will get into it, but it's very deep. I mean, if you start with matrices, it has some starting point, but it is so deep that you will just go deep dive into it. So we need not to know each and everything, but these are some of the things that we must know when we it comes to matrices. Then determinants. So basically, when vectors, we talk about vectors, we talk about matrices, and when we talk about matrices, automatically we talk about determinants. So how to find the determinants of 2 by 2 matrices, 3 by 3 matrices, then in what condition we can find out the determinants, what are their properties. So there are some of the relationships that goes with determinants. So just basic idea, we need not to go for 4 by 4 matrix or 5 by 5 matrix. If you know, that is very good thing. I mean, that's really good that you know how to calculate. But as the dimension of the matrix increases, then automatically the thing that happens is, uh, so the calculation part gets very complex. So we can say that it causes overfitting and we don't want it. So we can think like, just 2 by 2. It's good to know that we know 2 by 2 and 3 by 3 matrices, how to find out, how to calculate them and what are their properties, how is their relationship with other things, like when we find out the inverse, what exactly happens. So these are something that we should know. Then comes system of equations. So there are linear equation, matrix representation, and solving. So basically, when we are given a problem, how will we form a linear equation out of it? Then how will we find out the values of x and y, let us say. So all these things we need to know. It's always good to know. Then very important thing, calculus, and very challenging. I would say this is something that most of the students are afraid of. Not exactly afraid of, but people are not too good in calculus. I have seen a lot of people, even I am not very good in calculus. I know basics, I know what is required, but I am not expert in it. I am not, just give me any question and I solve any question. I am not in that condition, but I know the concepts, what exactly it is. I mean, what is a chain rule, what are different types in which we can find out the derivative. So basically I have basic understanding of everything, but I'm not expert, and we don't want to be an expert here as well. So basically, limits and derivatives is a simple topic. Integration is, I would say, a challenging part to do, but limits and derivatives are simple, and they are, I would say, NCRTs or any 11th standard book where all these topics are covered, 12th standard books, you should prefer them. So what a right hand limit, left hand limit. So then derivatives. So derivatives, there are 5 to 6 types in which, there are 5 to 6 variations in the derivatives, the way the derivative questions are asked. So basically we need to find out them only. What is the chain rule, quotient rule, then the product rule. There are basically different rules whenever we have quadratic equation, what exactly we do to solve them. So limits and derivatives are comparatively easy. I don't say they are completely easy, not at all. They are comparatively easy as compared to the integration. So I would say prefer any 11th or 12th standard book, no matter which board it is. I would prefer NCRT, but any 11th 12th standard book, or just to understand it basically. As I said, we don't need to be an expert there, so I won't say just go directly and solve any reference book, start referring to this book. We can start with very basic books like our board exam books, or NCRTs are my personal favorite. I mean, I like using NCRTs. I use mostly NCRTs. So then partial derivatives. So these are again, if you are good with derivatives, then I would say partial derivatives are, I mean, doable thing. Then gradient. So basically we have algorithms like gradient descent. They are nothing but we find derivative only. This is a fancy name of saying derivatives, a gradient, because in so there is an algorithm, gradient descent. It's not actually algorithm. We are trying to minimize the loss function in gradient descent. It is not an algorithm. It is a concept that we use for minimizing the loss function. Again, gradient descent has different methods or different types. So basically gradient descent is something that we should know. Gradients are nothing but derivatives, again fancy, some few additions in it, but there are some concepts or algorithms where we heavily use gradients, so we should know them. Then optimization, maxima, minima, again in like gradient descent, and there are few algorithms in machine learning where we require maxima, minima. So all these concepts that we should know. Integration is not that important for, right, to start with. I don't think integration is that important. There are like area under the curve or applications. When we go to deep, like when we start learning it thoroughly, I mean, well, if you are a beginner, I would say just knowing basic integration, or just how to find the area under the curve, or what are different types of integrations, if we know that, I would say that is enough to begin with. Then we have probability. So basically not I won't say that the questions of dice or the basic questions that we used to solve in 10th standard or something, they are not going to be enough. We need to know what is a conditional probability, what is a sample space. So basic concepts. So start with basics. What are the basic, what is the event, how to find out what is different addition rule, multiplication rule. So all these basics, so these are something that we have studied in 9th and 10th standard, I would say. And but very importantly, the most important thing in probability is conditional probability. What are the dependent events, what are independent events. So they are basically naive Bayes theorem. So here is what we need to learn, what exactly is Bayes theorem, because naive Bayes theorem, we have a detailed video where we talked about naive Bayes on my channel. So where we have discussed that exactly the Bayes theorem, how it is that we exactly use. There is not a single variation in Bayes theorem. It is called Bayes theorem, it is its name, but what we use is the exact formula of Bayes theorem. So we should know it. And then what is variance? So basically statistics, I would say, this variance, standard deviation. So basically you need to start with mean, mode, median, then gradually you should go to variance, standard deviation. So basically these are some of the parts are covered in probability, so I have considered it here as well. So just start with basic statistics, automatically you will come to variance and standard deviation. Then probability distribution. So again in any 11th or 12th standard book, you can automatically, I mean, just come up with all these things, so you need not to refer to any other book. This is what I feel. Then we have statistics. So statistics starts with mean, mode, median, basics. Start from that. Mean, mode, and median, these are something that when statistics comes, you know it will never happen that you can't take name of these three. This have to come. Then we have range, interquartile range. Then we have different standard deviation, then even hypothesis testing and everything. So start with basic, and I would say statistics is simple. It's not as difficult as calculus. So just start with mean, mode, median, their relationships, then go for standard deviation, variance. Then automatically you will study the concept of percentiles, then quartiles and interquartile ranges. Then automatically you will go for hypothesis testing and try to know what Z test is, T test is. Right now you need not to know it just to begin with, but later on you can just give a thought to it also, that learning that can help you. Then data visualization. So what happens in machine learning, we have a huge amount of data, millions of data points. We have tremendous amount of data. So visualization helps to actually understand it. Whenever we see something like these are the things, so it is better for our understanding. So that is why visualization is also an important concept. We should try to learn them. Then we have correlation, covariance, like in linear regression, this correlation, how are features correlated, how are they related to each other, how to find out them. So in algorithms like linear regression, logistic regression, these concepts of covariance and correlations are important, or they are heavily used there. So we should know what exactly they are. Then sampling, these are very simple thing. If you start with the basic probabilities and the basic statistics, this will come up with it. Then this is quite advanced part, as I said. So hypothesis testing, null testing, hypothesis. So there are a lot of things. What is p-value, type 1 error, type 2 error. So this is a huge topic, I would say. But to start with, just focus on, I would say, descriptive statistics. So this part and then this part. And I would say this will come, you will cover some of the things in probability section as well. And this too, specifically, I would say. You should know right now. And then just start with it. Then the last one is optimization. So optimization is not actually that important, but we should know basically what exactly optimization tells you is that we have different models. So in less time, in less amount of resources, which model will best fit for your use case, and a few things like this. So these are something that you should know, good to know part. But to start with, most important four things are the linear algebra, calculus, and statistics and probability. These are must know things. Optimization, again, gradient and everything comes here as well. So start with basics and just try to just start with something. And so that is all for this video. If for any specific topic in this video, if you want a more detailed video and want me to discuss few things, or make a like what exactly functions are, if you want a video like that, please let me know. I will be happy, more than happy, to make a detailed video on topics that you will suggest me. So that's all for this video.